Hello students, welcome to Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we are going to solve this problem from chapter 14, Hibbeler Dynamics. And the problem says that when the 150-pound skier is at point A, he has a speed of 5 feet per second. So the velocity at A is 5 feet per second, and we are required to determine his speed when he reaches point B on the smooth slope. So we have to find the velocity at point B. So VA is given, that is 5 feet per second, and we have to find the velocity at point B, and the point B is located at a distance of 35 feet from this origin in the horizontal direction. And it is said that for this distance the slope follows the cosine curve. Also, what is the normal force on his skis at B? So we have to find an B as well, and his rate of increase in speed. So we have to find the tangential acceleration at point B as well. The rate of increase in speed is always the tangential acceleration. And it is said that neglect friction and air resistance. So for that, if I consider the normal and tangential coordinates, so the normal coordinate is going to act towards the center. This will be our normal coordinate, and then tangent to the path will always be the tangential axis. So this is our tangential axis, and the weight of the skier is going to act vertically downward. This is the weight, and the normal force of the surface is going to act in the negative n direction. So this is the normal force. Now to find the velocity at point B, we need to apply the work energy principle from A to B. So according to the work energy principle, the kinetic energy at point A plus the summation of the work done due to the external forces from A to B will be equal to the kinetic energy at point B. So now the kinetic energy at point B will be 1 divided by 2 mass. So mass is, the weight is 150, so mass is 150 divided by 32.2 into VA square. So VA is 5 plus, now as we can see that when the skier is moving from A to B, the displacement is traveled along the tangential axis, and this normal, the surface force, is always perpendicular to the displacement traveled. So this means that n is not doing the work done on the skier. So the weight, the only work is done due to the weight. And as we can see that initially when the skier is somewhere here, the weight is acting downward and he is traveling the vertical distance along the downward direction, that is in the negative y direction. So the displacement is traveled in the negative direction and the weight is acting in the downward direction. So the work done due to the weight is the positive work done. And as we know that the work done due to the weight is always equal to the weight times delta y. So we have to find the change in the vertical position of the skier from A to B. So we have to find the y coordinate of the skier at point A, and then we have to find the y coordinate of the skier at point B as well. So let's say that here this is YA and here the y coordinate is YB. So we are given this y as a function of x, so we need to find YA. So YA will be equal to, we can find YA when we put x equals to 0, since the x coordinate of the skier at this point A is x is 0 and the y coordinate is YA. So when we put x is equal to 0 in this equation, we will be able to find YA. So YA will be equal to 50 cos of pi divided by 100 into 0. So cos of 0 is 1, so this gives us 50 feet. So the y coordinate of the skier at point A is 50 feet. Then to find YB, we need to put x equals to 35 feet, since here xb is 35 feet. So we need to put x equals to 35 feet in this equation. So this will give us the y coordinate of the skier when it is at a distance of 35 feet from the origin in the horizontal direction. So this is 50 cos of pi divided by 100 into 35 or we can say that this is 35 pi. Let me write this as 35 pi divided by 100. And remember that this angle is in radians. While calculating this value, we need to convert the calculator into radians. So I will convert the calculator into radians, and then that is 50 cos of 35 pi divided by 100. So this gives us 22.70. Let me write that this is 22.699. This is 22.699 feet. So now the change in the vertical position, that is delta y, is YA minus YB. That will give us the work done due to the weight. So the work done due to the weight is the weight. So weight is 150. So I will write 150 multiply by delta y, and delta y is YA. So YA is 50 minus YB, which is 22.699, and this will be equal to the kinetic energy at point B. So the kinetic energy at point B will be 1 divided by 2, and the mass is 150 divided by 32.2 into VB square. So now if I divide this whole equation by 150, so this will cancel out, 150 will cancel out, and this will be cancelled out. So we will be left with, this is 5 square. So 5 square is 25 divided by 2 into 32.2 plus this is 50 minus 22.699, and this is VB square divided by 2 into 32.2. So let me calculate this. This is 25 divided by 2 into 32.2 plus 50 minus 22.699. So this is 27.689, 27.689, and this is equal to VB square divided by 2 into 32.2. So if we multiply both sides of equation by 2 into 32.2, this will be 2 into 32.2. So we will get VB square, and if we take the square root, that will give us the velocity of the sphere at point B at x equals to 35 feet. 2 into 32.2 multiplied by 27.689. So this is 42.23. So VB equals to 42.23 feet per second. Now we have determined the velocity of the sphere at point B. Now we are asked to find NB. So to find the velocity, the normal force on the sphere at B, we have to find the slope. We have to find the angle of this weight with the normal axis, and this angle is equal to the angle of the slope, right? Let's say if I draw the free body diagram, let's say that somewhere here, let's say that this is the slope. So let's say I represent that slope here, and this is the location of the sphere at point B. So the normal axis is downward like this, and this is the tangential axis. And let's say that here this slope is making some angle theta. So this is that angle theta here as well. So now this angle theta will be, we can find this angle theta using this small triangle, and this is the change in y, and this is the change in x. So from this we can say that tan theta is equal to dy by dx, and we are given this y as a function of x. So when we find the first derivative of this y, and then when we put x equals to 35 feet in that equation, that will give us dy by dx value. So now the y equals to, let me write that y is equal to 50 cos of pi divided by 100x. So if we take the derivative of this, so that will be 50, and the derivative of cos is sine. So I will write sine pi divided by 100x, and then the derivative of the angle. So the derivative of the angle is pi divided by 100. So 100 divided by 50, so that is 2. This is pi divided by 2. So this is pi divided by 2, and the derivative of cos is minus sine, so we have to write minus sine here. So this is minus sine of the angle into pi divided by 2. So let me write pi divided by 2 here. So this is the first derivative, and if you want to find the angle of the if you want to find this angle, so then we have to put that x equals 35 feet in this equation. So that would give us tan theta. So tan theta, this is minus pi divided by 2 sine of pi divided by 100, and x is 35, so we can write this is 35 pi divided by 100. So this is minus pi divided by 2 sine of 35 pi divided by 100. And remember that the calculator is in radians, since this angle is in radians. So this is minus 1.399. So tan theta minus 1.399, and if we take tan inverse, that will give us the angle. So theta tan inverse of this answer. First let me convert the calculator into degrees so that we can get the angle in degrees. So then now I will write tan inverse, and that is minus 1.399. So the angle is minus 54.44. So this is minus 54.44 degrees, and the minus sign indicates that the angle is in the counterclockwise direction. So this is the angle. The angle is in the clockwise direction, right? The angle is made in this direction. So now here the slope is making, or this line is making, the tangent line is making 54.44 degrees with the horizontal. Now as we can see that the normal force is perpendicular with this tangent line, this is the normal force, and the weight is perpendicular with the horizontal line. This is the weight. So if we extend the line of action of this weight, so this is perpendicular with the horizontal line. So the angle between this tangent and the horizontal line is theta. So the angle between the weight and the normal axis is also theta. So now we know that this theta is 54.44. So now if I resolve this weight into its components, so this one will be the cos component, this one will be W cos of theta, and here we will have the sine component. So this is W sine of theta. So now we can apply the summation of forces along the normal axis. So now if I apply the summation of forces along the normal axis, so the summation of forces along the normal axis, this will be equal to MAN, and as we can see that the normal force is acting in the negative n direction, so I will write minus n, and this cos component of the weight is acting in the positive n direction, so I will write plus. Weight is 150, cos of theta is 54.44, and that will be equal to the mass. So mass is 150 divided by 32.2, and as we know that An is Vb square divided by, let me write that this is Vb square divided by rho, and the radius of curvature at point B. So now we have this Vb value, we need to find the radius of curvature at point B. So now Vb is 42.23 square, and we have to find the radius of curvature, and we know the equation for the radius of curvature from the kinematics. So let me write that equation. The radius of curvature will be equal to 1 plus dy by dx square to the power 3 divided by 2 divided by d square y by dx square, the absolute value of that. So now if you want to find the radius of curvature at B, we need to put the x equals to 35 feet. So now we need to have the second derivative of that y of x function. So now the first derivative is this. So now from this we can write that the second derivative d square y by dx square will be equal to, so this will be minus pi divided by 2. The derivative of sine is cos pi divided by 100x, and now the derivative of the angle is pi divided by 100. So this will become pi into pi will become pi square, and 2 into 100 is 200. and now I need to put x equals to 35 in this equation. So this is pi squared divided by 200 cos of x is 35, so we can write this is 35 pi divided by 100. So now again we need to have the calculator in radians. So convert the calculator into radians and then find that value, that is minus pi squared divided by 200 cos of 35 pi divided by 100. So this gives us minus 0.022. Let me write 0224. Now if I put this value, this is the dy by dx value when x is equal to 35, and this is d square y by dx square value when x is equal to 35. So we need to put that in this equation. This is 1 plus, that is dy by dx value is minus 1.399 square to the power 3 divided by 2 divided by the absolute value of d square y by dx. So the absolute value is plus 0.0224. So now that is 1 plus 1.399 square to the power 3 divided by 2 divided by 0.0224. So this gives me 227.02. So the radius of curvature at point B is 227.02. So now we can put that radius of curvature value in this equation. So this is minus n, and that will be, let me write this term on the other side of equation. So this is 150 divided by 32.2 into 42.23 square divided by 227.02, and this will become negative. So this is minus 150 cos of 54.44. And now if I multiply both sides of equation by negative sign, so this will become negative and this will become positive. So now from this equation we get n equals to 50.64. So this is 50.64 pounds. This is that n value at point B. Now we are also required to find the increase in the speed, the rate of increase in the speed. So we have to find the tangential acceleration. So for that we have to apply the summation of forces along the tangential axis, and that would be equal to mat. And now from the free body diagram is we can see that along the tangential direction we have the sine component only. So we have w sine of theta, so we will write plus w, and w is 150 sine of theta, and theta is 54.44, and this will be equal to the mass. So mass is 150 divided by 32.2 into at. If we divide both sides of equation by 150, so this will cancel out, and if I multiply both sides by 32.2, this is 1 divided by 32.2. So at from this equation is 32.2 sine of 54.44. This is 32.2 sine of 54.44. So this gives us 26.19. So 26.19 feet per second square is the rate of increase in the speed. So we have determined the velocity of the skier at point B, which is 42.23. We have determined it from work energy principle. Then we have determined NB using the summation of forces along N. So that gives us 50.64, and then we have determined the tangential acceleration, the increase in the speed. So that is by applying the summation of force along the tangential axis. So this is the solution of this particular problem. I hope this will help you in your learning. Do hit the subscribe button if it helps in your learning. Also like this video for the solution of such more problems from Hibbeler Dynamics.